have a question. You're not wearing a tie.
Okay, so you use the endpoint coordinate.
Okay. So what I have on number 1 is 2 different ways that you can show the midpoint. Now, the first way I showed you is what we talked about in here because we use the definition of midpoint. So we're showing that we're adding up our 2 x's and dividing by 2 and getting the x value at the midpoint. Adding up our 2 y's, dividing by 2, and getting the y value at the midpoint. But let me erase some of this so that it makes sense so you can watch me write it. When I taught the SAT class, we were all about shortcuts. But our shortcuts kind of look like what we just did with transformations. So for this to be the midpoint, this distance between here and here and that distance between there and there would have to be the same distance in the same direction, wouldn't it? Same distance, same direction.
Vector.
So it is the same vector.
See, I'm just smart.
Exactly. So we didn't write it in terms of vectors. We wrote it in terms of translations. But what would I do with this x to get to there? I would have to add 5. What would I do with this y to get to there? I would have to subtract 11. Do you see how this transformation takes this point to this point?
Yes.
Well, now, for this to be the midpoint between here and here, it would have to be the exact same transformation, wouldn't it?
Yes.
Whoa.
So this point right here would be, what is 2 plus 5?
That's the answer.
7. What is negative 5 minus 11? Negative 16.
What?
So you can think of it as that translation vector.
That makes it so much easier.
Yeah.
Oh, I see.
That's just another way to look at it. So you can do it either way, whichever way you like. Now, this is the distance formula. They gave us the distance, so we plug in a 13. They gave us the 0.37, so we plug in a 3 and a 7. They gave us an x value of negative 2, but we don't know the y, so we just plug in y. When you don't know something, you use the variable. So then we solve this by squaring both sides. Negative 5 squared is positive 25. And when I subtract that from 169, I get 144. So we have 144 equals y minus 7 squared. So I take the square root of both sides, and I get plus or minus square root of 144, which is positive or negative 12, is equal to y minus 7. So 7, when I move it to the other side, it becomes positive 7. Plus or minus 12 is y. So y is either 19 or it is negative 5. So those are the possible y coordinates.
Okay.
Take a look at that. It is just like the example on your notes. So make sure you bring your notes tomorrow.
I think we're gonna have a quiz.
Huh. Interesting. All right. Use the distance and slope formulas to determine the type of triangle. So what I did was I used the distance, and I got square root of 5, square root of 85, square root of 80. I got 3 different side lengths. So that tells me it is scaling. Now, if I use slope, I can determine if it's scaling right or not. And when I found the slopes of the 3 different segments, I got a slope of 2, a slope of 6/7, and a slope of negative 1/2. Do you see that these two are opposite reciprocals? Which tells us that those 2 segments are perpendicular, right? And perpendicular means right angle. So this would be a scaling right triangle. Okay? Good.
Just like on the homework.
Yeah. Wait. Okay.
You're proving.
Okay. These are the answers to your homework. Now, some of you, when I walked around, did not have the math. Let me tell you, on a test or quiz or a learning task, if you don't have the math to prove, if you just have a picture and go, hey, that one looks like a rectangle, or hey, that one looks like a, we can't do that. We have to have the math to prove. And this told us what to prove it was. Show that it forms a parallelogram. So parallelogram, I have to show 2 pair of parallel sides. So I found the slopes of both those sides. I have 2 pair of opposite line segments with the same slope. Therefore, I have a parallelogram. Does that make sense for number 1? Okay, number 2, they want us to know that we have a square. Well, a square, I have to have 2 pieces of information. And I can pick a couple different ones from that chart where we checked them off. It doesn't always have to be the same. But I do have to know that I have 4 congruent sides. And I can know that I have 4 right angles. Or I could say that the diagonals are congruent.
How do you prove that there's right angle?
How do I prove they're right angles? I showed that the slopes of those lines are opposite reciprocals, which shows that they're perpendicular, and if they're perpendicular, they form right angles. So that's what I did here. You can see that first I used the distance formula and found all the distances. Now, when I taught distance formula, I said the distance formula comes from the Pythagorean theorem, correct? So instead of actually doing the math on here, since it's on a grid for me already, I just counted up 1 over 4. 1 squared plus 4 squared is square root of 17.
Whoa.
Over 1, down 4. 1 squared plus 4 squared is the square root of 17. And I did that for every single point. All right. Then I went back at this number 2, and I looked at all the slopes. So I found every slope. Do you see that the slopes are all opposite reciprocals? Which tells me that where those lines intersect, they are perpendicular, which means right angle. And that's what I need. Okay, questions about number 2?
So, where's that? What's the bottom left? H? The bottom left. Like,
Mine is, yes, it's H.
Did you grab the rope?
up there.
No.
Yeah, but I'm still trying to grasp it.
Okay, the other 2 we can see are 5. We're supposed to show that it's a parallelogram, so we have to show that opposite sides are parallel. And number 6, we're supposed to prove that the diagonals are perpendicular bisectors. That's a 2-part problem. 1, we have to show that the diagonals are perpendicular. So we find the slope of one and the slope of other, and the slopes are opposite reciprocals. So we know that they are perpendicular lines. And we also have to tackle the bisector part, which means that each diagonal bisects the other. Now, bisect means to cut into 2 congruent parts, right? And doesn't the midpoint of a segment do that? The midpoint of a segment divides a segment into 2 congruent parts, doesn't it? So, if we find the midpoint of both of these, which I did, the midpoint of FH, and I got negative 1/2, positive 9/2, and I found the midpoint of EG, which is negative 1/2, positive 9/2, and those midpoints are the same, which means that FH bisects EG, and EG also bisects FH. So they are bisected. So those 2 diagonals are perpendicular bisectors. And that's the way you show it, midpoint and slope. Any questions about number 6? Okay, did you guys write down the ones that you were not responsible for doing last time?
Yes.
So that you could have them in case I did something that was open notes soon, which is probably why I told you to bring your notes.
So confused. What did you just say?
You just said you write down the answers to the ones you didn't do last time.
No, I didn't. Should I do that? Yeah, I do that.
Either that or go on my website tonight and print them out. Because we're about to move. All right, let's take a look at the last 4. Take a look at these. Make sure. Number 3, rhombus. For a rhombus, all I have to know is 4 congruent sides. If it's a quadrilateral with 4 congruent sides, it's got to be a rhombus. It could be a square. So I might want to show that this, the lines do not have slopes that are opposite reciprocals. But this said just prove it is a rhombus. So showing the 4 congruent sides will do that.
Why are there so many loopholes in geometry?
Are we supposed to know to change the 3
It's like
and
the
the
law.
5?
No. This was my, I'm bad about flipping numbers. which is not good considering what I do for a living. But
Teach other children.
yeah,
Therefore,
yeah,
that problem.
I confuse lots of children.
Until there's one.
So for you, number 4's answer should be, it is not a rectangle. Miss Willoughby, you're crazy. All right. So what if you were reading my brain and went, oh, obviously, Miss Willoughby, you meant 5-3, not 3-5.
Was I supposed to?
No, you're not
It was
supposed
just
Everything's
like,
supposed to figure
I
that
was
out.
kind
but
of
it
tired that night. I'm like, you know what? I'm just gonna write down some math. Proved it wasn't.
Okay.
I would laugh,
Why
but
is this a
sometimes we
rectangle?
do that with my children too.
So you find the
Because-
slope of these?
You actually did that.
Yeah, for a rectangle, we're going to have 4 right angles. So if we find that the slopes are opposite reciprocals, we're good.
Well, mathematically.
You can do it. But you yes, you can. Considering you can prove parallelism.
Okay, number 7 asks us to prove that it forms a right triangle. And so to show it forms a right triangle, all we have to do is show that the lines are perpendicular, so the slopes are opposite. It is actually an isosceles right triangle, but it just said prove that it's a right triangle. You can prove it's isosceles by finding the distances, the lengths of the 2 legs. And that's what we had to do on number 8. We had to show opposite reciprocal and that those distances were the same. And then that tells us it's an isosceles right triangle.
So you have to find.
And I will put these notes on my website after we're done. So if you just want to print this stuff out, you certainly may.
Yeah, I probably will.
Yeah.
I probably won't remember.
Woo. Maybe you should send yourself a message.
Or my mother.
Oh, set an alert for your phone.
Yeah, I don't know.
First table was 20.
Oh, you don't have one of those? Oh, I'm sorry. Oh, that's not what I meant to do. Okay, so I want you guys to see if you can do something similar. We're going to do one of these a day, so we can continue to practice. So you don't forget.
Yes, I love yellow.
Here we get yellow today. Yeah, it's nice.
I don't
Okay, guys, try number 1. Please try number 1.
That's all we are.
I love It's not a real thing. You're not crying on me. Dang it. Crying on your cat. Yeah.
Wait, what is
Complain to me. Why is it?
PQ slope is
Wait, I'm dumb. So you just don't parentheses first, huh?
I'll figure that out.
I just remembered I was trying to.
Wow,
It
stupid.
was on the internet. Wait, what's the
Why too much for one over there?
Yeah, you can move this way. Yes, you did. You're not funny.
The distance.
well, so
Who's better than that?
She's in calculus, and I'm in accelerated.
You're an Acaag.
Yeah, she's in calculus.
That's, you just proved that smart. You excel in math. You're in math.
Not necessarily because she's at the same point. I'm going to be better than
How do you know that, Brian?
See, but we don't. That is the thing.
How do you know she would be so much
Okay,
better?
honey, let me break it down for you.
She's better than
Diet. Diet.
She's better at eating.
Yes, right, so you can simplify the fractions, right? Just take out the negative side, you can divide those by 3, so it'll be 4 over 3.
So you have to quit
Right.
math and start
And
applying.
that's
Yeah,
the
I'm
same
never gonna
slope,
do that.
it's PQ. So the definition of it, yes, it is,
It's still in the system.
no, it's not because you can cancel out the sum, it's just dependent on both.
There's a one spot for on someone actually.
Okay, so did we determine the slopes?
Yes,
And did you show that there's only one pair of parallel lines?
yes.
Okay, so that takes care of the trapezoid part, right? So the slopes take care of the trapezoid part.
PQ.
Now we have to figure out how to handle the isosceles part. Well, the isosceles part, you'd have to show that the other two sides are congruent. And then you ought to be able to explain that in words. We have proved that quadrilateral PQRT is an isosceles triangle because you can see that only one pair of lines have the same slope, therefore one pair of parallel lines, and the other lines are congruent. Got it? Yes.
We have to, when we're doing the opposite sides congruent, can we just find the two that are congruent, or do you have to find all of them?
You can just find the two that are congruent. Now, if you are having to prove what type, instead of them telling you what type, to prove what type, you would have to do all of them to make sure it's not a rectangle.
Okay.
But it's common sense.
It is.
Yeah.
That's what I hate about this.
But let's say I gave you really big numbers that didn't fit on a grid. What would you do?
I would guess.
Okay, fair
Depends,
enough.
am I paid to?
This is your job. School is your job right now.
This will be, I'm confused once you get into the second part, once you get the square roots going on, that's where I get lost.
I used the distance formula and found the distance between P and T.
So you,
And I got it was the square root of 50. Simplifies to 5 root 2. And then I used the distance formula again between Q and R. So I used the distance formula twice. So if you have to show congruent sides, you're using distance. If you have to show parallel, you're using slope. If you have to show perpendicular, you're using slope. If you have to show bisecting, then you're using midpoint. Okay, I'm going to do number 2 on your homework with you. It's classwork homework. I'm going to get you started. And so today, we're just kind of taking what we did yesterday and tweaking it just a tiny bit. Today, I'm giving you all but one of the vertices. And then we have to determine what the missing vertice could be. Vertex could be, sorry. Vertice when it's plural, vertex when it's singular. Okay.
That's an equilateral triangle.
I don't remember where I was going.
So we're going to do number 2 together because it's the harder one on the page.
Thank you.
All right. I'm very visual. So the first thing I always do is sketch a picture. We are given a graph here so I can actually plot it. The points 3, 2, go ahead, and 3, 8 are 2 vertices of an equilateral triangle. So I'm going to connect them because I know they will connect. And I know there are 2 of the vertices on this equilateral triangle. Okay.
Guess on these.
Can I guess? If I want to miss it. Okay, I'm just going to draw a picture of an equilateral triangle for those of us who may or may not remember. Okay, now, if I drop down a perpendicular on an equilateral triangle, what does it do? It splits it in half. So it is basically going right through the midpoint of this side, isn't it? So do you see if I gave you one side, this one, and you're trying to find this vertex out here, do you see it lies on the same line as that midpoint? How would that help us here? Okay, what do you think?
Find the midpoint.
Find the midpoint, which is pretty easy because this line is 6 units, so the midpoint would be halfway, wouldn't it?
Yeah.
And so we know that that third vertex lies somewhere on the line that passes through that midpoint. That perpendicular bisector to the midpoint. So that third vertex falls somewhere on that line. So we already know something about that ordered pair. What do we know? We already know the y. What is the y? The y is 5. Okay. What else do we know?
So, we know.
Okay.
It's an equilateral triangle. All the sides have to be the same.
Good. All the sides have to be the same length. So what is the distance of every line segment? 6. So we know the distance from here to wherever that point is on this line has to be 6. The distance from here to wherever that point is. And if we think about it, that point could be over here or over here, couldn't it? I did. Not really. Not really. But we know a distance. We know a point. And we know what the y value of the other point has to be.
So,
Oh, that looks awfully similar to the warm-up we did, doesn't it? When we go back to our distance formula, distance equals the square root. Oh, that is not even close to a square root symbol. Let's try again. The square root of the difference in our x's squared plus the difference in our y squared. So I know with my other point the y is 5, but I don't know what that x is. So I'll say it's x2, 5. So I've got this point and this point that I'm finding the distance between. And I know that distance is 6. So 6 equals the square root of x2 minus, I'm just picking the first one. I could have used either point. I just chose the first one. 3 squared plus y2, which is 5, minus y1, which is 2, squared. And then I have to solve this. So to solve this, I'm going to square both sides.
okay.
And I get 36 equals x minus 3 squared plus, what is 5 minus 2? 3. And when I square it, I get 9. So what can I do with that 9?
Move it over.
Move it over. Subtract it from both sides of the equation. And so you get 27 equals x minus 3 squared. Then what do? Then you do. You take the square root of both sides. And when you take a square root that wasn't there, it is positive or negative. And so this simplifies to 9 times 3. Square root of 9 is 3. So 3 root 3.
Let's go with that.
And then we move the 3 back over, so we get 3 plus 3 root 3, or 3 minus 3 root 3, or our two x values. So I'm supposed to write my answer as the two possible points. So I would write it as 3 plus 3 root 3, comma 5, and 3 minus 3 root 3, comma 5. So that one actually has two possible solutions. Now, I did the decimal approximation on my calculator just so I could plot it where it goes on the, I got 8.1968 here. So 8.1968 would be about right there. Does that look like it makes one? Yeah? And then this one is negative 2.1. So that would be somewhere right around here. And that makes another one.
No, it's not right. It's off. Good job. You're wrong.
I want exact answers.
I don't like exact.
But, you know what? If you're good at drawing, you can do an approximate and get to your exact answer as a check step.
That's the consolation.
All right.
Yeah.
You have the remainder of class to work on the rest of these.
1, 3, 4, 5, 6, 7. Okay, here we go.
If it's not finished,
The rest of them are homework.
that's
So
what.
you have the rest of class and then finish for homework.